Hi everyone, welcome to my channel Design with Roosevelt. Continuing with CSWA practice problems, today we'll work on question 5.3. Let's take a look at this question. So in this question, unit of measurement is millimeter gram second. Like always, we need to ensure we are using the same unit of measurement in SolidWorks setting. Now, looking at this geometry, you can see that we have the top view of the geometry, we have the 3D model, section AA, and view C. My preference is to start with the top view. I want to focus on the base of the geometry, which is this section. So I'm going to make a 2D sketch of base of the geometry, then I'm going to extrude that and make that part. Next, after that, I'm going to focus on this feature. In order to make this feature, we can simply make a plane, make a sketch on that plane and extrude that. So with this introduction, let's jump into SolidWorks and start modeling this part. In SolidWorks, first we need to check unit of measurement, and you can see that we have millimeter gram second, which is a correct unit of measurement. Now I click on a sketch, I click on the sketch command, and I choose top plane. Of course, here we need a rectangle, so here I click on drop down menu and I choose center rectangle, and this is a 2D sketch. Now, looking at the question, you can see that the width of this geometry should be 88 millimeter. Also, the height of this should be 62 millimeter. Now, if you look at the top view, you can see that we need chamfer in the corners. The dimension of the chamfer is 6 millimeter by 45 degree, which means that it's 6 by 6. In order to add chamfer, you can go to sketch, you can click on the drop down menu, and then you click on sketch chamfer, and the size equal distance is selected, so I just change this one to 6 millimeter, and I select this corner, this one, and this one. Click on OK. Next, we need to make 2 slots on this geometry. In order to make a slot, you can make it from scratch, but the easier option is here. You can see that we have a straight slot option, and you can click on it, and then all you need to do, you can click on this point, that's a starting point. This is basically a center line of the slot. You click on the second point and you get your geometry. Okay? Now we can add dimensions. The distance between left wall and left side of the geometry is 8 millimeter. The width of this slot should be 6 millimeters, so this is 6. The distance between first center point and second one is 41 millimeter. And finally, the distance between the center point of the circle and a bottom edge should be 10.5 millimeter. And now you can see that with all these dimensions, this slot is fully defined. Now, in order to have it on the other side, I can simply use mirror command in this sketch mode. So from the sketch, all you need to do is to go to mirror entities, and then here I need to have basically a center line or a mirror line. So before that, let's click on line command, click on center line, and let's make a center line like this. Now I can click on mirror entities. For entities to mirror, I want to mirror this slot, and then click on mirror about, and now you can choose this center line, and now you can see the preview. Click on OK. Awesome. Like always, if you remember, when you use mirror command or linear sketch pattern, circular pattern, most of the time the geometry, the resulted geometry is not fully defined, so it can simply move, right? You can see that this can move, and the reason is pretty much clear. You can see that as it rotates, the center line or a mirror line is also rotating, so I can find the root cause here. You can simply click on this mirror line and choose this constraint. I want to make it vertical, and now as soon as I make it vertical, you can see that the mirror geometry is also fully defined. Awesome. Okay, so now we have everything. For the base of the geometry, we know that the thickness is going to be 7 millimeter according to section AA. So all I need to do, I can click on feature, click on extrude bus, And then here I'm going to change the thickness to 7 millimeter. Okay, so that's the base of the geometry. Next step, we need to focus on making the second part of the geometry. In order to do this, first I need a plane. And if you remember from the previous video, if you want to make a plane, you need a reference line. So let's make a reference line. Click on a sketch, and click on this surface. If you look at the top view, you can see that the plane that we are interested in should pass through the center point of this circle and this half circle. So in order to do this, I click on line command and choose center line. I don't see the center point of this half circle, but in order to see that, hover your mouse on this section, and now you can see the center line. Click on it, and same thing for the other side. And this is the center point of the other circle. Click on it, and that's it. So that's just a sketch, and that's going to be used as a reference to make our plane. Exit this sketch. Next, we want to make a plane. In order to make a plane, you can click on Feature, and then from this drop-down menu, Reference Geometry, you can choose Plane. Now, the first reference that I want is going to be this line. And again, SolidWorks shows you the preview, but as I explained in a previous video, you need at least 2 references. The second one could be simply this top surface. We want this plane to be perpendicular to that surface. So click on it, and now you can see that the plane is fixed. And here in the status, you can see that it's fully defined, which is a good sign. Click on OK. Next step, we want to make a sketch on this plane. So click on a sketch, and choose plane. In order to make this part of the geometry, you can take a look at section AA. Section AA shows you the second part of the geometry. So let's start by making a sketch here. Click on line command, and then I start from here. I go up like this, then like this, and basically something like this. First of all, looking at section AA, you can see that the height of this section should be 20 millimeters. So this is 20. The width of the top section is 4 millimeters, so this is also 4. Also, you can see that the angle between this line and horizontal line should be 36 degrees. Okay, so far, what we have is not fully defined. We added some of these dimensions, and here's the part that you need to do small mental math. Let me go back to the question. I want to show you something. In the question, you can see that the distance between the center line of the circle here, the hole that we have, and this vertex or the point is 8 millimeters. But finding that arbitrary line is kind of difficult at the moment. However, if you look at view C, you can see that the overall width of this section is 14 millimeters. The width of this section is equal to diameter of the curve that you see here. You see the fillet here? The diameter of that fillet is equal to the width. So the diameter of that fillet is 14 millimeters. In other words, the radius of the fillet is 7 millimeters. So basically, the radius of that circle or fillet is 7 millimeters. This distance is 8 millimeters. So overall, we need 15 millimeter distance here. Okay? So let's apply that to our model. So basically, in here, what I can do, I can click on center line. First, let's make a center line. I want this center line to be perpendicular to this line. And this is a center line of the hole. Now, looking at view C, we know that the distance between this edge and this center line should be 7 millimeters. Why? Because the diameter is 14, the radius is 7 millimeters. Also, we know that the distance between this center line and this edge should be 8 millimeters. So this is 8 millimeters. Now, looking at this geometry, you can see that still the geometry is not fully defined. The reason that it's not fully defined is because we're missing one dimension. If you look at the top view, you can see that we are having one more dimension, the distance between the edge of this feature and center line of the hole in the slot is 20 millimeter. Let me just rotate this for a second. Basically, what we need is this distance, this point to this point. According to the top view, we know that this distance should be 20 millimeter. And now, once I add the dimensions, you can see that the geometry is fully defined. Okay, awesome. So now we have everything. We have a fully defined sketch. All we need to do is to extrude this geometry. In order to do this, click on Feature, click on Extrude Boss, and then here, because it's a symmetric feature, I change this to midplane. And according to view C, we know that the width of this feature should be 14 millimeters. So I change this point to 14. Awesome. So now we have this feature. Okay. Next step is to make this edge or this part of the geometry kind of round. In order to do this, all we need to do is to use fillet command. So from feature, I click on fillet command. And then here for the fillet, because it's a full round, I can simply choose this option. This option gives you a full round fillet. And in order to use this feature, all you need to do is to select 3 different surfaces. So I select this surface, then this one, and finally this one. And SolidWorks automatically shows you the preview. Click on OK, and that's it. Last step, we need to make a hole in the center of this geometry. So click on a sketch, and choose this surface. Let me hide this plane. We don't need that plane anymore. So you can click on the plane and then from the options choose height. And then here I need a hole. The diameter of the hole is 8 millimeters. So I click on circle command, and then here the center point of this circle is here, and I draw a circle. Click on the smart dimension, the diameter should be 8. Now all I need to do is to use extrude cut feature to make this hole. Click on feature, click on extrude cut, and then here, as long as this extrusion passed through the whole depth of the geometry, we're good. We don't really care. So you can simply keep it as 14 millimeter depths, or from the options, you can choose up to next. They are basically the same. Click on OK, and that's it. Awesome. So I think that's it. We modeled every single features in this geometry. Now it's time to check the total volume and make sure that this is a correct model. Let's go back to the question and check the total volume. In the question, you can see that the total volume is 40,316 cubic millimeters. Let's go back to our model and check the total volume. In SolidWorks, in order to check the total volume, you can click on Evaluate, then Mass Properties. And here you can see the total volume. The total volume for our model is 40,316 cubic millimeters. This is exactly the same as what we have in a question, which is showing our model is correct and there's no problem with it. Okay, awesome. I think that's a wrap for this video. I hope you guys enjoyed it, and if you have any question or comments, please leave comments down below. Thanks again for watching. My name is Ruzbe. Hope to see you again soon in the next videos.